For the given circuit, we will try to find Thevenin's equivalent circuit for terminal AB and for terminal BC. So let's do it first for AB first. When we want to find the Thevenin's equivalent for AB, we have to find the open circuit voltage here. What is the VOC here? That will be the Thevenin's equivalent voltage. So we have a current source and a parallel resistance here, and this is the terminal here. So we can actually do the conversion. We can convert it into a voltage source and a series resistance, because these two terminal, this is just one terminal basically, this is not affected. So we can do that. So what I will do, I will go to the next page and then I will do the conversion there. So it's there, there, and then here it will be 5 ohms there, and this will become a voltage source. So 24 volts, this one, 2 ohms, that's a 3 ohms, that's a 4 ohms, that's a 5 ohms, and this one is the there's a 1 ohms resistance there. So that's a 1 ohm resistance. That's terminal A, this is terminal B, and this is terminal C. Nothing is changed there. The value of the voltage source here will be 10 volts. That's there. So this is our new circuit. We need to, now we can see there is no current can flow in this direction, because these two terminals, this is open, there is an open circuit. So there will be only one current like that, and there are two voltage sources. The direction of the current will be like that in the clockwise direction, because the two voltages are opposing each other, voltage sources, and this one is of higher value. So essentially the value of the current will be 24 minus 10, the resultant EMF, electromotive forces, divided by sum of these four resistances. So 2 plus 3 plus 5 plus 4, so 9 and 12 and 14. So this is 14 over 14, that's 1 ampere. So current of 1 ampere will flow in this direction. So the voltage drop across the terminal, across 4 ohms resistance will be 4 volts, and there will be no drop here. So the open circuit voltage in this case will be that drop, which is 4 volts. So that's the Thevenin's voltage there, which is Thevenin's voltage as well, as seen from terminal A and B. And if we want to find the resistance as seen from here, we have to make all the voltage sources short circuited. There is only voltage sources now. So this one, this stays there, this one there, so like that, and this one there, and this one there. So we want to find the resistance as seen here. So this is 4 ohms, 5 ohms there, that's a 2 ohms, this is a 2 ohms, and this is a 3 ohms. So what happens is these three resistances are coming in series, and it is becoming in parallel with the 4 ohms resistance. So 5 plus 2 plus 3, that is 10 ohms, 10 ohms in parallel with 4 ohms, and then that's in series with the 1 ohms. So like that, this is what's becoming. So the resistance R Thevenin here will become 1 plus 4 parallel 10, which is 1 plus 4 times 10 over 14. So that's 2 there, that's 7 there. So basically 1 plus 20 over 7, or 7 over 27, like that. Let's leave it like that. So that is our Thevenin circuit. So the voltage source is 4 volts, and the resistance is 27 over 7, and then here we can connect this is our A and B. So that is our Thevenin's equivalent for terminal AB. Now let's do the same thing for terminal BC. We don't have to do the whole calculation once again. So the drop, the same current will flow, only we are now interested in the open circuit voltage across terminal B and C. So this one, what's the voltage there? So the same current will flow, everything else will be the same. Only the voltage drop across the 5 ohms resistance will now become 5 volts because the current is 1 still. So that's 5 volts, and we are interested in the voltage across this terminal. So we have a drop of 5 volts here and a drop of 15 volts here. So that's how it is. So the BC, voltage BC, which in this case BC, which is V Thevenin now, will be 5 plus 10, which is 15 volts, because this is one drop here and another drop here. So from terminal B to C, the voltage drop is 15 volts. So that's there. Now let's look at what will be the resistance seen from here. So now we have to find, I'm making the sources inactive, so this there, and this one is there, this one is there. So I am interested now of the resistance as seen from here, and this one is there, this one is there. So this is 2 ohms, this is 3 ohms, that's 4 ohms, that's 5 ohms, and this is 1 ohms. Now this 1 ohms has no importance here because this is there is an open circuit here, no current will flow there. So since we are interested about the resistance as seen from here, this 1 ohms is of no importance now. So what we have now is 4 plus 3 plus 2. These three resistances are coming in series. So basically these three resistances are coming in series and then becoming in parallel with the the 5 ohms resistance. So 4 plus 3 plus 2, that's 7 and 9. So basically 9 ohms there and parallel with 5 ohms. So this is the Thevenin's resistance, which is RBC, we can say. So that's 9 over 5 over 9 plus 5, which is 14. So this is 45 over 15 ohms, and that is the RBC, R Thevenin. So when we look at the terminal from BC, the equivalent Thevenin's circuit for BC, for terminal BC, it will be V, that will be 15 volts here, which is V Thevenin's, and this one will be 45 over 14, which is the Thevenin's resistance, and this will be terminal BC, which in the previous case it was this was terminal AB for the other terminal. So these two are the Thevenin's equivalent circuit.